Okay, now moving on to our next task. Task number 3, we will try to simulate a real-world example, which is called water pumping. This is my water pumping scenario. Suppose that we have a lake or river or something like that, and we want to use a pump to pump water through a tube up to a reservoir in our house, up the hill. This reservoir has a volume of 5 cubic meters, and I need to buy a pump which is able to fill this tank in 1 hour. Okay, so what is the required pump power, and what is the available net positive suction head of this pump? All pipes have 1 inch diameter. Okay, so the question is, can we do this on DWSIM? Yes, the DWSIM can do this, can model this case, and we can simulate the pump and the pipe and the tank and everything else. So this is what would be our process diagram for this case. We have the reservoir water body, maybe a lake or a river, and it goes through the suction pipe to the pump, then from the pump to the discharge pipe to the tank in our house. So you will notice that this is almost the same representation that we will be building in the DWSIM. Okay, so let's do it step by step now. Let's create a new simulation. I've saved our simulation from task 2 already. Let's create a new, add water, select Steam Tables, Property Package, the Flash algorithm we can leave it default, System of Units SI, okay, maximize the window. So the first tip I would give to you is to disable the flowsheet calculator while we build our model. Otherwise, it will keep trying to calculate the objects as soon as we enter the properties, and that's a little annoying. So let's add our pump. Oh, centrifugal pump is here. Drag, oh, drag it up. Now let's add our suction pipe. Piping segment is the block that models that. Another one for the discharge pipe. We can also add tank. Okay, what we will use to connect these objects? Of course, it is our material strings. You can either drag and drop, or you can select the object and click on this little thunder icon. It will create and connect the material stream to the object, in this case the pump, for the inlet stream. But I already added one. Let me select it from the drop down menu. The pipe, I will do the same. Material stream number 4 will be our inlet stream, number 5 our outlet stream, and the energy stream will be a stream carrying energy, which will close the energy balance in this block, I'll use this button to create the outlet stream for the pump. You see that it was created and connected automatically. And we also need an energy stream connected to the pump, which will represent the power required by the pump. Okay, so let's connect material stream 7 to our discharge pipe, create a new one for the outlet stream, another energy stream. The tank model in DWSIM, it's an object to calculate the residence time only. It doesn't do anything else. So I've added it so we can calculate the time that will take to fill this tank indirectly. Okay, so here is our process diagram. Okay, let's go back to the slides for some definitions. You will notice that we've added a few objects to the flow sheet, and these objects are called unit operations. The unit operation is a basic step in the process. It involves a physical change or chemical transformation such as a separation, crystallization, evaporation, filtration, heating, cooling, etc. etc. The material stream, we've already worked with it. It represents process fluid streams connecting two or more unit operation. It represents what enters or leaves a unit operation. Okay, and the energy stream represents process heat entering or leaving the unit operations to close the energy balance. Okay, these are our main objects that we use to build a process model in the DWSIM. Let me save simulation. I'll name it task 3 water pumping. Okay, so what is the data that we have to input in our model? We have the temperature of the water reservoir, we have the pressure, which is atmospheric pressure, we have the length of the suction pipe, we also have the length of the discharge pipe, we have the volume of the tank, and we also have the pressure of the tank, which is the atmospheric pressure. We have the diameter of the pipe too, and we need to calculate the pump power and the net positive suction head that is available on this system. Okay, so let's start our input data in the DWSIM, inputting data in the DWSIM. So what do we need to insert here? Once we enter information in the inlet material stream and all unit operations, the DWSIM will calculate each one sequentially until it gets to the end of the flowsheet, which is found once he finds material string that is disconnected at its outlet port. Okay, so this is why DWSIM is called a sequential modular simulator, steady-state simulator, because it goes calculating each object at a time until it gets to the end of the flowsheet. So for material streams, we only need to enter information at the first one in the flowsheet. If we had another stream here, we would have to enter information on it too. Energy streams depend on the object to which it is connected. So in this case, this energy stream will be calculated by the pipe, and this one will be calculated by the pump, this one by the pipe. Okay, so let's start inputting our data. We already have full water stream here. Let's enter our temperature, 25 degrees Celsius. Our pressure, okay. Don't worry about the mass flow now. We will change it later in order to calculate the pressure of the outlet pressure of the pump. Let's enter the information at the pipe. You will see that we have a general tab here. We need to specify the calculation mode. We will leave it at the default selection, which is the specify length option, because we have the length of the pipe. Don't worry about these things now. We only need to enter the hydraulic profile of this pipe. We have a straight tube. Material, I forgot to say, it is PVC. So we should select it on this length, 0.5 meters, elevation 0.5, because it's going straight up to the pump. And if you double click at this box, you will see a shortcut to input a standard dimension for the pipe, which is this one I've selected is the 1-inch standard schedule 40. Click apply changes to store the profile. And now the next pipe. Notice that we have 4 sections in this pipe, one with 2 meters, another one with 100 meters which goes up, 20 meters, another 4 meters going straight up, 6 meters until we get to the tank. So let's enter this information in the DWSIM window. Let me choose this to make it easier to input the data. So the first section, we have 2 meters, elevation 0, 1 inch. Let's add another section of straight tube. Oh, forgot to change the material. This one has 100 meters, elevation 20 meters, 1 inch, After you select the option in this list, you must select another cell on the table in order for the value to appear in the cell, okay? So the third section is 4 meters up, 4, 4. And the final section ABC, 6 meters, 0 elevation. Okay, let's apply changes. Here is, you can see on the View tab, the diagram showing the pipe profile. Okay, you can use this to check if you inputted everything correctly. Okay, don't worry about the thermal profile now. We will see this in another course. We will deal with this in another course. So let me bring the windows back to normal. And finally, let me hide this window for now. Let us enter the volume of our tank, 5 meters, 5 cubic meters. Okay, so now we can try to calculate the flow sheet. Let's reactivate the calculator and solve flow sheet. Okay, so what do we have here? We have an error message saying that a negative pressure was calculated inside the pipe segment, which is the discharge pipe segment. Why? Because our pump still we haven't defined the pump outlet pressure yet. We can do that in different ways. We can set the pressure increase at the pump, or we can set the outlet pressure. We can enter the power required by the pump, or we can use the information from the energy stream, or we can use performance curves for our centrifugal pump. But for now we will try to set the outlet pressure until we get an atmospheric pressure at the outlet of the second pipe segment, which is what we need in our system. So suppose that our pump has an outlet pressure of 120,000 pascals. Still not enough for our pump, to push the water up on the hill. So let's try another method. Nothing yet. We can already change the volumetric flow of our water stream, because we know that our tank has 5 cubic meters, and I know that I need to fill this tank in 1 hour. So we can just, but actually the DWSIM doesn't have the liters per day unit, so we will have to do a simple calculation. 0. Our pump pressure is still not enough. Now it calculated pressure. Almost what we need. Now I'm going to show you how to display these properties of interest a little easier. DWSIM has a feature that enables you to add tables to the flowsheet. We can go to Insert, Property Table, and it will add this box to the flowsheet. You can drag it around, and if you double click on it, you can choose properties from objects in the flowsheet to display in this table. So let's select our inlet material stream conditions, the suction pipe pressure drop, the discharge pipe pressure drop, our pump head efficiency, and power required, and also the pressure at the outlet of the discharge pipe, which is the same pressure of the material stream number 9. Okay, so we have it here. You can do a right click and edit the appearance and edit the appearance of this table. You can change the font details and spacing and colors and border and everything else. So let me just increase the size of the font. The header. It seems that I can't change the font of the object ID, so this is something I'll have to fix later. Let me save our simulation. So let's change the units of the residence time so we can check if it is close to 1 hour or if we did everything correctly. Edit simulation settings, system of units, create new, change the temperature, pressure to ATM, volumetric flow rate to liters per hour. Here is the time variable. Hour. Now select. Something's not right here. It is 5,000 liters per hour per day and 208.3 per hour. 24 hours. No. Again, I did it wrong. Now it's correct. 5,000 1000 liters per hour. Let's try another pressure. 6. If we have, I think we need to lower a bit. Almost there. Quite. Okay, let us stop by now. So we can see that DWSIM calculated the power required by the pump if we consider an efficiency of 75%. Actually, in order to see the NPSG of this pump, we need to open the simulation in the other user interface. Okay, so I'm sorry about that, but I'll fix this in the next release. I don't know why I removed it from the classic user interface. If we run the simulation, we will see the available NPSG for this pump at the results report. 9.7 meters. Okay, so we'll go back to the cross-platform relay later. Okay, but for now, let's go back to classic user interface. Okay, guys, so this is all for our task 3. You can see that we can simulate this process really easily in the DWSIM. We can check the results of each calculation. When you click on the object, you see it's the editor, and if after the object is calculated, you can see the results on its own editor. This is the case for the pump. For instance, we see the power required by the pump. In the discharge pipe, we see the pressure drop. We see the heat load, which is the heat lost by the water because of the flow through the tube. We see the profile data and profile graph. This is the length of the tube and the pressure profile. We can also see the liquid velocity, 2.49 meters by second, and other properties. Okay, so let me save it again, and we're done with task 3. Okay, so if you want to create a report with the results from the simulation, we can go to results, create report, and here we can select the objects that you want to include in the report. I'll include everything. You can change the order of the objects in the report. You can select some options from the material streams to display. If you want to view the report, you can click on this button. Here is the report. It includes all properties from the objects. This is the pipe segment, properties for each. This is calculation. You can print this report, or you can click here to print it, or you can export the data to a file. You can export to an XML file, a text file, an Excel spreadsheet, an open document spreadsheet, or an open document text. I'll export to a ODT file for us to see how it looks like. So let's open the file just. Here it is. It is a little different from the report, but you have the same data in this document. Okay. So now let's move on to the next task.